All right, we're doing Cal 1. This is we're going to be talking about antiderivatives and indefinite integration. So it's not going to be that bad, I promise. I'll make it real easy for you. The first question we're going to answer here, well, it's not a question. We're going to find something. We're going to find an antiderivative, f of x, and this is the antiderivative of, and this is a small f here, of f of x equal to 4x cubed. So let's get busy working some examples. We have um, f of x is equal to 4x cubed. Now I'm going to write over here, I'm going to write y is equal to x to the fourth. Now you should see some kind of relationship between these two, and that is, okay, let's go back to when we were taking derivatives in the previous section. Let's take the derivative of this right here. Well, the derivative is 4x to the third, right? Bring the 4 out front and subtract 1 from the exponent, and we have y prime. Well, guess what? And we're going to label this as our capital F here. That's what I meant to do. X to the fourth. I was about to rewrite it. Okay, well, it turns out that this is the antiderivative of f of x. So what are we doing here? We're going backwards. We're giving you this equation here, which happens to be a differential equation, and we're going back in reverse order. So we took derivatives going in this direction, but now we're going back in this direction. So in other words, you're given the derivative, and we want to trace our way back to what the original function here was. So we call this the antiderivative, right? The derivative and the antiderivative. Okay. Now, if you remember, I said, you see this word right here? Okay. This word means that there's more than one antiderivative of f of x. So for example, the antiderivative could possibly be, here's another one. We'll label it as we'll label this as 1 and this one as 2. That's an antiderivative of f of x up here, or f of 3, we'll label this as f of 3 there. F sub 3, I should say. X to the fourth minus 10, let's say. And you're probably going, how is this an antiderivative of the small f of x? Well, once again, look back at what's going on here, okay, when we went in reverse order. What we're going to do is we're going to take the derivative, and I'll just do that right here. So to check if this is an antiderivative of our original up here, to check that, all we have to do is take the derivative of this. So in other words, I'm going to write f2 prime of x, and the derivative of this is 4x to the third. So on all of these, we're going to be able to take the derivative of the antiderivative to get back this function up here. Okay, so now hold on, what about this piece here? Well, this is a constant, and when you take the derivative of a constant, it's just 0. So that's the reason nothing's written over here. And of course, same thing goes with this. We got minus 10, but when we take the derivative of this constant, we get 0. So once again, this is going to be equal to 4x to the third when we take the derivative of this. So what could we say about this? Well, we could say this. We could say that the antiderivative, if you take the derivative of the antiderivative, you should get back what that original function was. Okay? So there you go. These two guys are equal. So when we solve these problems, when we take the derivative of them and we get back, right, this, then that means that we've done it correctly. So that's all there is to this entire section basically on integration, really.